Hi guys, my name is Paul, and today we're going to look at Challenge 11, Baker Hughes's challenge with Simba and Ramen. So, problem statement, we'll go into further depth in later slides about this. So, essentially, we have data from P6 Primavera, and it basically stores the actual percentage progress of a project over time, as you can see plotted on the grey line. And essentially, Baker Hughes has several theoretical lines which the project should be working along according to data from previous projects, which can be seen in the blue. This is 27 of the theoretical curves. 21 of them are smooth and 6 are not smooth.
Yeah, so our methodology we took to tackle this problem. We first cleaned the data and normalized it. So this involved getting rid of activities from P6 that had not yet reached completion, as well as making sure that all the very short and very long activities were mapped to the same 0 to 100% duration. And then step 2, we looked at the actual curves of those activities and compared them to the theoretical templates, and taking the square error and comparing them that way to see how well they perform. And we'll show you some charts for that. Step 3, we looked at for each activity across all of those 27 theoretical templates, which one would have been best with the benefit of hindsight. And we'll show you some pictures of that. And the fourth and final step was we looked at, instead of the pre-existing 27 template curves, we asked the data to tell us what are the best curves for fitting these. And we used a couple of different algorithms to suggest those curves, and we'll show you those at the end.
So the results. This is a tree map, and the area here shows how often a theoretical curve was used. So if you can look there, curve number 20, 15, 1, 22, and 12 are the most used curves. And then the color there shows you green is showing the most successful curve by the least error, and red is showing the worst performing curve, i.e. the most or the biggest error. We call this the confusion matrix because it's quite difficult to explain, but what this is doing is step number 3. Our algorithm went and looked at all the activities that had been completed and appropriately assigned the best theoretical curve that could be assigned there. So you can see the darker colors in that matrix show that most of the time curve 17 is the most appropriate curve, followed by curve 26 and 27. The next slide simplifies this a bit. So we took the top 6 curves, and we've suggested that Baker Hughes can replace the assignment of those curves with the following. And gold means that's the best performing, silver is the second, and bronze is the third.
And just to give you an example, the top set of activities, many activities were classed as 20, and we were suggesting that 17 is better. So that's the 2 thick lines here. And then we took a few dozen of the activities just to show you that they actually fit 17 better, although 17 is not perfect. And then, so this is step 4 of our methodology. The first algorithm we tried was this k-means. It's not known for being very good at giving you useful answers, and you can see there's way too much overlap here. It's difficult for a planner to choose between these templates. So then we tried a different algorithm, the Gaussian mixture model, which gives you slightly more spread out templates that might be a little bit easier, but there's still a lot of overlap, and this suggests that possibly you don't need 27 template curves to choose to allocate your different activities to.
So the next steps, we need to investigate the discrepancies between the actual start and the finish dates when compared to start dates. We need to discuss deployment with Baker Hughes. We need to consider updating planning standards to reflect the recommended improvements and share the insight with the greater community.
Question. So we had 3 questions. One of those is which activity profiles best fit, best and worst. So the best one was a curve 1, which was just a linear line. And the worst one was curve 15. As you can see there, it goes to 0 and jumps up to 100% at the very end.
And just to clarify, these are the curves that were assigned by the planning team rather than by us in our software in the further steps of the methodology.
Yeah. And then the second question was, does the activity type affect does the activity profile vary by activity type? And with this, you can see that clearly activity 27 is modeled better by the theoretical curves, and activity 20 is not. And then the final one is in terms of reallocation. We did cover this, and this is how we suggest using the gold, silver, and bronze. Thank you.
Thank you.
Thank you.